welcome back to another M&S tutoring video, and in this video we're going to be starting our second unit in grade 9 science, chemistry. In today's video we're going to be learning about the Bohr-Rutherford diagram as well as the Lewis dot diagram. And we're going to be learning when we can use both of these diagrams and how we can draw these diagrams as well. So as we are beginning our second unit in grade 9 math chemistry, I advise you, if you're watching any of my videos, please be sure to have a periodic table beside you so you can refer back and forth between the video and the periodic table if you have any miscommunication errors or anything of that sort. So if you have your periodic table beside you, that's great. If you don't have one currently at the moment, it's completely fine. You can still watch the video, but for our next few videos, just please be sure to have a periodic table beside you. So let's get started with the Bohr-Rutherford diagram. So the Bohr-Rutherford diagram can be used for the first 20 elements in the periodic table. So I'm going to write the Bohr-Rutherford diagrams. So it can be used for the first 20 elements, right? That means any elements between, including and between, hydrogen to all the way to calcium, right? So the Bohr-Rutherford diagram is just a general diagram used to show the different electron shells, the protons and the neutrons in the actual element itself. So something to remember when looking at the periodic table that you'll need when you're actually drawing the Bohr-Rutherford diagram is to remember that the atomic number of the element in the periodic table, which in this case is, for let's say oxygen is 8, is actually the number of protons in the actual element. So something to remember is atomic number is the number of protons, right? Another thing to remember is the number of protons is also the number of electrons. So the number of protons is equal to the number of electrons, right? And the last thing you have to remember when looking at a periodic table is the atomic mass is the number of the protons plus the number of neutrons. So the number of protons plus the number of neutrons is equal to the atomic mass, right? These are the three important things you have to remember when you're drawing a Bohr-Rutherford diagram as well as looking at the periodic table. So the atomic mass is the weight of the element itself, and it's usually on the top right section of the element itself. So aluminum's atomic mass is 26.98, and remember always the atomic mass is never perfectly accurate to a whole number because the atomic mass of each electron and each proton and neutron varies between each element or each singular atom. And the atomic mass for oxygen, of course, is 18, and the atomic number for oxygen is 8, and the atomic number for aluminum is 13. So let's begin to draw a Bohr-Rutherford diagram for oxygen. So oxygen is the 8th element in the periodic table, having an atomic number of 8. So when we're drawing, we need to remember that we need to start with the center. So when I'm drawing oxygen's Bohr-Rutherford diagram, I need to start with the center of the oxygen. So at the center of any element's atom, we have the protons and the neutrons. The protons, as I mentioned before, are the atomic number. So the atomic number of oxygen is 8. So there are 8 protons in the center. So we write 8p. Neutrons are also in the center, and remember neutrons are basically neutrons plus the number of protons is equal to the atomic mass. So in this case, since the atomic mass is 16 and we have 8 protons, simple math, 16 minus 8 is equal to 8 neutrons. So we write over here, we write 8n, right? So if we look at this, we get 8 plus 16, sorry, not 8 plus 16, 8 plus 8, which gives you the number, which gives you the atomic mass, right? So now let's focus on actually drawing the electrons in the electron shells in the actual diagram itself. So the one thing you have to remember when drawing the electrons is the electron shells go in a format of 2, 8, 8, and 2. This means in the first electron ring, you can only have a maximum of 2 electrons. And in the second, you can have a maximum of 8, and the third, you can have a maximum of 8, and then the fourth one, you can only have 2 electrons again. So if I draw my first electron ring, right, I can only have a maximum of 2 electrons. And to figure out how many electrons are there in an atom of oxygen, we have to look at the number of protons. And since we know that there's 8 protons, there has to be 8 electrons, since the number of protons is equal to the number of electrons. So I can draw, an electron is just a dot on the shell, so I can draw 2 of my electrons right here on the first shell. And I can't draw any more because the first shell only supports a maximum of 2 electrons. So I'm going to draw my second shell now, right? Now that I have my second shell, I can draw in a maximum of 8 electrons. But currently, I only need 6 more electrons to fulfill the number of oxygen electrons. So I can start by the top, and I can draw 6 electrons. So I can draw 1, 2, 3, 4. It's not really important in which order you draw the electrons, but try to keep it as balanced as you can. So I usually like going in a clockwise manner and try to balance out the electrons. So you can see in the second shell we have 6 electrons, in the first shell we have 2, making it 8 electrons, and that's basically it. You've drawn a Bohr-Rutherford diagram of the oxygen atom. Now, since oxygen has such a low number of protons, and which means it has a low amount of electrons, any other element, say for example element 20, you'd have to draw a lot more rings and a lot more dots, and it'd be a lot more tedious. So another way you could do it is instead of actually drawing the dots, you can just draw the center with the same thing, 8p and 8n. And instead of drawing the dots, you can just state how many electrons are there in each ring. So you can write 2e, which means 2 electrons. And then the second electron ring, you can just simply write 6e, right? And that's another way to draw a Bohr-Rutherford diagram for oxygen. So now let's look at the Lewis dot diagram. So for me, Lewis dot diagrams are a lot more simple than Bohr-Rutherford diagrams, as all the shells and all the electrons are not really involved. So the Lewis dot diagrams are used to show the outermost electrons on the last electron shell of each element. So in Lewis dot diagrams, you don't really care about the first shell of an element itself. You care about the outermost shell. So say for example for oxygen, you wouldn't really care about the first shell of electrons here. You'd only worry about this shell of electrons over here, the second shell. And that's one of the main features of a Lewis dot diagram. A Lewis dot diagram is mainly used for elements that when you're bonding, you want to see how the electrons on the outside will react with each other. So that's usually when you would use a Lewis dot diagram. So let's get started, and I'll show you how you can draw a Lewis dot diagram. So the first thing you have to do is, say we're doing it for the same thing. Say we're doing it for, actually no, let's do it for aluminum this time. Say you're drawing a Lewis dot diagram for aluminum. What you have to do is you have to write the chemical name. So you'll write Al, and not the entire name, just the short form for the element. And what you really have to do is you have to look at how many outer electrons it has. So aluminum has 13 protons because the atomic number is 13. And since it has 13 protons, we also know it has 13 electrons. So the 13 electrons will be distributed in this scale. So there's 13, and we know the shells consist of 2, 8, 8, and 2, right? So it will be distributed as 2, right, 8, and then 3, right? And these are the shells of the aluminum element. So this is the innermost shell. So inner. This is the middle, and this is the outermost shell. Now, what you have to focus on is the outermost shell. Since there's 3 valence electrons, valence is just another way of saying the outermost electrons. We have to draw 3 different electrons on the scale. So all we do is draw one dot, another dot, and another dot. And that's all it is to a Lewis dot diagram. All you have to do is you have to draw the outermost electrons. So the Lewis dot diagram is really helpful because it determines how different elements bond and react with other substances as it looks at the outermost electrons. So that's the end of the video, guys. I hope you now know how to draw Lewis dot diagrams and Bohr-Rutherford diagrams as well. If you have any comments or concerns, please feel free to leave a comment down in the comment section below, and I'll get back to you as soon as possible. And as always, thanks for watching, guys.